Hello everyone, welcome to my class. Till now we have discussed about amines, nomenclature, classification, preparation methods of amines, physical properties of amines, basicity of amines, and comparison of basic nature of alkyl amines and aromatic amines. And also we have discussed about phase transfer catalyst and also discussed about the amines chemical properties like a reaction of amines with nitrous acid, reaction of amines with the Hinsberg reagent, oxidation reaction of amines, reduction reaction of amines, reaction of amines with alkyl halides, reaction of amines with the acyl halides. Like that, we have studied all the chemical properties of amines. And also, we have discussed about how to distinguish the primary, secondary, tertiary amines from the mixture. Also, we have discussed. And also we have discussed about what is diazotization, and also from the diazonium compound how to prepare the different types of the aromatic substituted compounds like chlorobenzene, bromobenzene, chlorobenzene, phenol, nitrobenzene. Also we have discussed in the last class. So today we are going to discuss about the cyanides and also isocyanides, their preparations and also properties. Today we are going to discuss. So first let us see the cyanides. Cyanides are nothing but the compounds in which an alkyl group is attached to the carbon of Cn. Cn is nothing but which is called as cyanide group or called as alkyl cyanides. The formula of alkyl cyanide which is represented as RCN. So, according to the IUPAC nomenclature, whenever cyanide group is present in the compound, then we have to add the suffix as nitrile. So, generally, common name of this compound is cyanide, whereas IUPAC nomenclature name is nitrile. For example, if you see this compound, so in this compound, the common name is called as, because this is one methyl, this is the one substituent. So according to the common name of this compound is cyanide. So this name is called as methyl cyanide, or also called as acetonitrile. So if you see the IUPAC nomenclature, total here 1, 2, 2 carbons are present. So whenever 2 carbons are present, then we have to write the ethane. Then cyanide name is nitrile. So we have to add the suffix as nitrile after writing number of carbons. So ethane, nitrile. So next example is here, total in this compound, total 3 carbons are here. So here this is the ethyl is the substituent. So common name is ethyl cyanide. Common name is ethyl cyanide. Whereas IUPAC nomenclature, total 1, 2, 3 carbons are present. So here, so propane, whenever 3 carbons are present, then we have to write the propane nitrile. This is the IUPAC name. So in this compound, so this is the propyl group is the substituent. So propyl cyanide is the common name of this compound, whereas IUPAC nomenclature total 1, 2, 3, 4, 4 carbons are present. Hence, so if 4 carbons are there, then which are in straight line, straight chain. Hence, this name is butane nitrile. So in this compound, so this is the substituent. This substituent name is called as total 1, 2, 3. 3 carbons are present, which are in branch form. So hence this compound name is called as isopropyl cyanide. And suppose if you see the IUPAC nomenclature here, total 1, 2, 3 carbons are present, which are in straight chain. But here this is the substituent which is in branch form. So here total 3 carbons at second position, which this compound is having the methyl substituent. Hence, we have to write 2 methyl. So, total 3 carbons are present, propane nitrile. So, like this, we can write the common name and IUPAC names of the cyanide compounds. Whereas isocyanides are nothing but the compounds in which an alkyl group is attached to the directly connected to the nitrogen. Whereas in cyanide, R group is which is connected to the carbon. But here R group P which is directly connected to the nitrogen. Then these compounds are called as isocyanides. So for this isocyanide IUPAC nomenclature suffix, we have to add the isonitrile. Whereas cyanides, we have to add the suffix as nitrile. For isocyanides, we have to add the suffix as isonitrile. So IUPAC name is written as alkyl isonitrile. For example, if you see this the formula, in this formula, this is the methyl is a substituent, and NC, this carbon which is connected with the nitrogen. So NC is called as isocyanide. So common name of this compound is methyl isocyanide. Whereas for this compound, IUPAC nomenclature, total one carbon is present. So methyl isonitrile, methyl isonitrile. Similarly, in this example here, total two carbons are present, which is the substituent. So ethyl isocyanide. So here also total two carbons are present. So ethyl isonitrile. So here also total three carbons are present. So propyl, for the common name of this compound is propyl isocyanide, whereas IUPAC nomenclature is propyl isonitrile. So coming to the cyanide structure, in the cyanide structure, carbon which is directly connected to the C, and also C and nitrogen, there is a triple bond. So here hybridization between the carbon and nitrogen, this hybridization is sp hybridization. Hence, bond angle between the carbon and nitrogen is 180 degrees. So it's a planar structure. So bond angle is 180 degrees. And also here the bond length of the carbon and nitrogen, because here the total bond order is 3. Hence bond length is very less, that is 1.16 angstrom. Because it is the triple bond order is 3. So bond length is very less as compared to this bond length is very shorter than compared to carbon nitrogen double bond in amines, and also carbon nitrogen single, this is not amine, this is the imines, and also carbon nitrogen single bond in amines, because always triple bond length is less compared to double bond length, next compared to single bond. So here the cyanide hybridization is sp hybridization, bond angle is 180 degrees, and also bond length is very less, that means very short bond which is present between the carbon and nitrogen. And coming to the isocyanide structure, in this isocyanide structure, nitrogen which is directly connected to the R group, whereas in cyanide, carbon which is connected to the carbon, so this is called as cyanide, whereas in isocyanide, nitrogen which is connected to the carbon. So here in this isocyanide also, which is also sp hybridization, here also between the carbon and nitrogen triple bond is present, hence this bond order is 3. This bond length which is shorter than C double bond N imines, and also C single bond N amines bond length. And coming to the preparations of cyanides, so first preparation from alkyl halides. Here alkyl halides, when it reacts with the potassium cyanide, in this alkyl halide, R is a plus charge, whereas halogen is more electronegative atoms, so halogen will get the negative charge. Similarly, in the potassium cyanide also, which is also in ionic form, so here potassium will dissociate as a K plus, whereas cyanide will dissociate as a minus. Cyanide is a minus. So here this compound is undergoing to nucleophilic substitution reaction. So here nucleophilic substitution reaction is nothing but in place of one nucleophile, another nucleophile is substituted. That is, X is nucleophile which is replaced by the cyanide nucleophile, finally which produces the alkyl cyanide. Alkyl cyanide. That means X is one nucleophile, this nucleophile is replaced by the cyanide, which produces the alkyl cyanide. This is example for the nucleophilic substitution reaction. So for this compound, one example is ethyl bromide when it reacts with the potassium cyanide. So here bromine, which is replaced by the cyanide nucleophile, so which produces the ethyl cyanide. And another preparation is from amides. Amide linkage is nothing but C double bond O NH2. This linkage is called as amide. So amides, when it reacts with the phosphorus pentoxide, this is the dehydrating agent. This is the dehydrating agent. So from here, from amine group OH2 and from C double bond O oxygen will eliminate as a water molecule. So here which produces the cyanide. So here first what will happen on the nitrogen in the amine which can having the lone pair of electrons which donate electrons to here. So simultaneously in C double bond with the pi bonding electron shifted to the oxygen and forms the enol. In the next step, this enol, this from the nitrogen, one hydrogen will eliminate, and from the enol, from the carbon, OH group eliminate as a water molecule and forms the one more pi bond. So finally, between the carbon and nitrogen, three bonds will be generated. This is the formation of the alkyl cyanide. So for example, if you take the benzamide, in this benzamide, when it reacts with the phosphorus pentoxide on heating, which produces the phenyl cyanide. This is the second preparation. And coming to the third preparation from aldoxime, when aldehydes, this is the R C double bond OH is called as aldehyde when reacts with the hydroxyl amine. This is the hydroxyl amine. When it reacts with the hydroxyl amine, so from this amine H2, from this carbonyl group oxygen will eliminate and forms the aldoxime. So here also nitrogen, which is having the lone pair of electrons, which donates its electrons to the carbonyl carbon. So simultaneously pi bonding electron shifted to the oxygen. So enol will form. So next step again, from this nitrogen one H is eliminated as a H plus, and from here OH minus eliminated as a water molecule. So elimination reaction takes place. So finally, which produces this aldoxime. This aldoxime on further hydrolysis, further reacting with the phosphorus pentoxide or acetic anhydride, then what will happen? Again, this compound will eliminate OH group, H group will eliminate and produces the cyanide. So for this compound, the example is acetaldoxime. Acetaldoxime, when it reacts with the acetic anhydride, this compound is called as acetic anhydride. When heating, then what will happen? From here OH group, from here H plus eliminated as a water and produces the acetonitrile. So these are the few preparations of methods of cyanide compounds. So coming to the physical properties of the cyanides, these alkyl cyanides are stable, neutral substances with having the pleasant smell. And lower members of alkyl cyanides are colorless liquids at room temperature, whereas higher members of cyanides are crystalline solids. These are less poisonous than the hydrogen cyanide. Lower members are soluble in water as they form the hydrogen bonding with the water. So whenever alkyl cyanides up to ethyl group, because they are having the less non-polar compound like organic compounds, hence could able to dissolve in a water molecule by formation of the hydrogen bonding. So whenever higher members are as the carbon number is increases, then organic nature is increases, hence they are not able to soluble in the water. Then higher number of alkyl cyanides are soluble in organic solvents. So these are the physical properties of cyanides. Coming to the chemical properties of the cyanides, so first one, when alkyl cyanides on hydrolysis, which produces the, so here complete this triple bond is undergoing to dissociation and produces the carboxylic acid as well as ammonia. this is triple bond is undergoing to dissociate. So this compound, this RC will convert as a carboxylic acid, whereas this nitrogen is eliminated as a ammonia. So for example, if you see the methyl cyanide, this methyl cyanide on hydrolysis, first which produces the acetamide, on further hydrolysis which produces the acetic acid as well as ammonia. So another example, ethyl cyanide on hydrolysis, first which produces the propanamide, then further on hydrolysis which produces the propanoic acid. So this is the hydrolysis reaction of cyanides. So on hydrolysis, all the cyanides will produce the carboxylic acids as well as ammonia. So coming to the reduction reaction, so reduction is nothing but addition of hydrogen or removal of oxygen is called as reduction reaction. So alkyl cyanides when react with the lithium aluminum hydride, this is the strong reducing agent. So in the presence of this reducing agent, all these double bonds will undergoing to reduce and produces the amine compounds. So by addition of the 2 moles of the hydrogen to this molecule which produces the amines. This is called as reduction reaction. Then another reaction is alkyl cyanides. Alkyl cyanide when it reacts with the Grignard reagent. This alkyl magnesium halide is called as Grignard reagent. Alkyl magnesium halide is called as Grignard reagent. Now in this Grignard reagent, R is dissociated as a minus charge, whereas magnesium, which is a metal, hence this Mgx is exist as a plus charge. So similarly, in the cyanide group also, nitrogen, which is more electronegative atom than the carbon, hence nitrogen is generally which is having the minus charge, whereas carbon which is having the plus charge. So in this is a alkyl cyanide when it reacts with the Grignard reagent. In this Grignard reagent, so R is existing as a minus charge. So here in this compound carbon which is having the plus charge, hence this minus charge and plus charge makes the bond. Similarly, in the cyanide, nitrogen is having the minus charge, whereas Mgx which is having the plus charge. So this minus and plus charge will make the bond. So finally, which produces the imine salt, which produces the imine salt. In the cyanide, this compound which is having the triple bond, whereas in this imine which is having the double bond. Now this imine salt or addition product on further hydrolysis, this double bond is undergoing to cleavage and produces the ketones. Because here this carbon which is connected with the two alkyl group, which produces the ketones, as well as this nitrogen will eliminate as a ammonia, and this Mgx is liberated as MgXOH. So alkyl cyanides on reaction with the Grignard reagent, suppose if methyl cyanide when it reacts with the methyl magnesium halide, then which produces the acetone. So like this, by addition reaction which produces the carbonate compounds. Next, coming to the isocyanates preparation. In this first preparation, alkyl halide when it reacts with the silver cyanide. As we are all know, in this silver cyanide, there is a covalent bond between the silver and cyanide. So no formation of Ag plus and Cn minus. So here in this compound, nitrogen which is having the more electronegative atom than the carbon. So nitrogen which is having the minus charge than the carbon. Hence here nitrogen in this silver cyanide. So nitrogen will donate the electrons to here alkyl group because this R group is deficient. In this Rx, R is exist as a plus charge, whereas X is exist as a minus charge. Hence, in this isocyanate formation, nitrogen will able to donate the electrons to the R. So directly R which is connected to the nitrogen. Whereas in cyanide formation, alkyl halide, when it reacts with the here, another reactant is potassium cyanide. In the potassium cyanide will exist as a ionic forms. So potassium K is exist as a K plus, whereas cyanide will exist as a cyanide minus. So their carbon is having the minus charge. But in the silver cyanide, which won't exist as a ionic form, so in this compound, nitrogen is a more electronegative atom, which is having the lone pair of electrons, hence which is involving in a nucleophilic substitution reaction. Therefore, in isocyanate formation, R group, which is directly connected to the nitrogen, and the byproduct is silver halide. So for this equation, the example is ethyl iodide when it reacts with the silver cyanide, which produces the ethyl isocyanide, and also silver iodide also will form. This is the byproduct. And another preparation method, this one we have studied in the amines reaction. So here only this is the carbylamine. This reaction also called as the carbylamine reaction. Only primary amines only will involve in a carbylamine reaction, whereas secondary and tertiary amines won't form the carbylamine reaction. So here, this is the primary amine because this nitrogen, which is connected to only one alkyl group, hence this compound is called as a primary amine. When it reacts with the chloroform CHCl3 in the presence of the basic medium, then what will happen? Which produces the isocyanide. This reaction is called as carbylamine reaction. Similarly, with alkyl amines also will involve, because this alkyl amine is a primary amine, whereas this aromatic amine also, which is also primary amine, so this compound also will involve in a carbylamine reaction. So this aniline, when it reacts with the chloroform in the presence of the base, this compound also will produce the phenyl isocyanide, and also potassium chlorides and water, which are the byproducts in this reaction. Next, coming to the physical properties of the isocyanides, alkyl isocyanides are colorless liquids. These are highly unpleasant smelling liquids. They are insoluble in water, absence of hydrogen bonds, but soluble in organic solvents. They have lower boiling points. Isocyanides are highly poisonous than the cyanides. And coming to the chemical properties of the isocyanates, the first chemical reaction is the hydrolysis reaction. So isocyanides on hydrolysis. So here N triple bond C. So triple bond is present between nitrogen and carbon. This triple bond is undergoing to cleavage and produces the amines. And this carbon here, only one carbon is present, that is on hydrolysis, which produces the formic acid. So isocyanates on hydrolysis, which produces the amines and formic acid. And second reaction is the reduction reaction. So isocyanides on reduction, that means addition of hydrogen or elimination of oxygen, is called as reduction. In the presence of any reducing agent, here we have taken hydrogen and platinum, which is a metal. So in the presence of this reducing agent, so here which produces the secondary amines, because here this nitrogen, which is connected with the two alkyl groups, hence this amine is called as secondary amine. So here this triple bond, which is present between the nitrogen and carbon, is undergoing to reduce and produces the secondary amines. And on oxidation, isocyanides on oxidation, which produces the isocyanates by heating with the mercuric oxide. So alkyl isocyanate, in this isocyanate, nitrogen, which is connected to the alkyl group. In this alkyl isocyanate, when it reacts with the mercuric oxide, that is HgO, then which produces the alkyl isocyanate. NCO is called as isocyanate. So alkyl isocyanate on oxidation in the presence of mercuric oxide, which produces the alkyl isocyanate. So for example, this compound, for this reaction, the example is methyl isocyanate when it reacts with the oxidizing agent, that is mercuric oxide, which produces the methyl isocyanate. This methyl isocyanate is highly poisonous gas. And if you see the comparison between the cyanides and isocyanides, coming to the solubility, these cyanides are soluble in water, whereas isocyanates are sparingly soluble in water. Lower alkyl member cyanides are soluble in water. Higher alkyl number cyanides are insoluble in water and also soluble in organic solvents. Whereas here lower number of alkyl isocyanates also sparingly soluble in water. And coming to the order, here these cyanides are pleasant smell, whereas isocyanates are highly unpleasant smell. Isocyanates on hydrolysis, which produces the carboxylic acids, whereas these isocyanates on hydrolysis, which produces the amides and also which produces the formic acids. So here cyanides on reduction, which produces the primary amines, whereas isocyanates which on reduction, which produces the secondary amines. So these are all the preparation methods of cyanides, physical properties of the cyanides, chemical properties of the cyanide, and also preparation methods of isocyanates, physical properties of isocyanates, chemical properties of the isocyanates. I hope you are all understood of the complete amines chapters and benzene diazonium salts, diazotization, as well as cyanides, preparations, physical chemical properties, isocyanates, preparation, physical chemical properties. So let us solve some problems on this chapter. So first question is, what is the Hoffman bromide reaction, reactant and product? Yes. In Hoffman bromide reaction, the reactant is amide. So when it reacts with the bromine in the presence of the base, which produces the amines. So here amides which are converting into amines, this reaction is called as Hoffman's bromide reaction. So next question is, write the basicity order of amines in water. So here what will happen? Here this is the ethyl amine, this is the primary amine, because this here nitrogen which is attached to the one alkyl group, so it is a primary amine. Next here this is the secondary amine, because nitrogen which is attached to alkyl group secondary amine, whereas this is the triethylamine, this is the tertiary amine. So among all these amines, which is we can say the basicity order is first secondary amines which are having the more basic nature, then the primary amine, then tertiary amine. As we are all know, on the nitrogen, if plus I groups are increases, basicity also increases. But in water, due to the steric hindrance, that is a triethylamine, this basicity nature will be decreases. Hence, the basicity order is first secondary amine, then the primary amine, then the tertiary amine. Next question, which of the following amine does not react with the Hinsberg reagent? As we all know, Hinsberg reagent which is useful to distinguish the primary, whether that compound given amine is a primary amine or secondary amine or tertiary amine. So Hinsberg reagent which reacts with the primary amine, which further reacts with the base and produces the salt. Whereas secondary amine which is also react with the Hinsberg reagent. Hinsberg reagent is nothing but benzene sulfonate chloride. So which further won't react with the base. Whereas tertiary amine, this tertiary amine nitrogen which is around the nitrogen, there is no proton. Hence this tertiary amine won't react with the Hinsberg reagent. So among primary, secondary, tertiary amine won't react with the Hinsberg reagent, because in this tertiary amine, nitrogen doesn't have the hydrogen. So next one is, what is the product formation in Siemens reaction? As we are all know, Siemens reaction is nothing but conversion of benzene diazonium chloride in the presence of tetrafluoroborate, so which produces the fluorobenzene. So in the Siemens reaction, the final product is the fluorobenzene. And next reaction, methyl magnesium bromide. This is the Grignard reagent. When it reacts with the methyl cyanide, then what is the product here? In this Grignard reagent, methyl is exist as a minus charge, whereas magnesium bromide which exists as a plus charge. Whereas in this methyl cyanide, so here nitrogen which is having the more electronegative atom, so which takes its bonding electrons towards to the nitrogen. So nitrogen will carry the minus charge, whereas carbon will carry the plus charge. So which is undergoing to addition reaction and produces the, this methyl will attack it to the carbon, whereas this MgBr will attack to the nitrogen on further hydrolysis, which finally which produces the acetone. So like this we have solved the all the problems, and we have discussed the complete amine chapter. I hope you are all understood the complete amine chapter, diazonium salts and cyanides, isocyanides, preparations and properties, everything. Okay, thank you for your patience listening. Thank you.